Showing that a formula is false always starts by plugging in numbers. Showing a formula is true involves many different methods. It could be geometry, it could be based on pizza diagrams or that exponent ladder. For exponent formulas, for certain exponent formulas, you may plug in numbers for the exponents only. But not for the base. You're just accounting for how many times a base appears. And you might rely on previously true formulas in order to get new ones. We'll see that we saw that very recently. Each true formula was discovered differently. Even if some were similar in process, how could the exact same thoughts lead to different true formulas? Again, with one exception, the exponent formulas, please do not plug in numbers to show that a formula is true. So last time we saw the definition of radical, namely that the nth root of a equals y, where y to the nth power equals a. We saw three exponent formulas leading to three radical formulas, and we also saw a to the 1 over nth equals nth root of a. And then finally, the nth power and the nth root undo each other. So let's simplify root c to the 10th power. So root c to the 10th power is the same as the second root of c to the 10th power. And just set up based on the definition using the same colors. What we're looking for is y. In other words, after the word where, there's this equation y to the second power equals c to the 10th. We need to think about what can fill the spot where y is. And we see that c to the 5th is going to work for where y is because using our exponent rules, this one over here that's highlighted in red, c to the 5th quantity raised to the second is what's going to be c to the 10th. Okay, there is that detail. And there we go. So the second root of c to the 10th equals c to the 5th because c to the 5th quantity to the second power equals c to the 10th. Okay, so there's that definition of radical again. We just saw that the square root, if I just leave out the little 2 or just say root c to the 10th is c to the 5th. Similarly, root c to the 12th is c to the 6th, root c to the 18th is c to the 9th, root k to the 44th is k to the 22nd. And in short, whenever you see root b to the t, so within the root you have a base and an exponent, the result is b to the r, where r happens to be t over 2, right? So the new exponent is half of the old exponent. In other words, just said more in words, when square rooting b to the t, the result is that the exponent is cut in half. So here's an alternate solution. If you'd like to look at the problem we just most recently did here, the second root of k to the 44th, I think going based off of the definition is actually the easiest approach, but if you want another way to do this, you can think about the second root as being a 1/2 power, and now that you have exponent and an exponent outside, that's the situation to multiply these exponents together. So let's turn that 44, which doesn't look like a fraction yet, into 44 over 1. Take your two fractions that are in the little exponent land and multiply straight across, and you have k to the 22nd. So you end up still with the same answer, k to the 22nd, as you see in the tan box. Okay, because if you leave out the little tiny 2 right outside the root symbol, it's just assumed to be a little 2. It's a hidden 2. So the examples that we just saw, which I just pasted from the previous slide, can also be written without the little yellow 2 just right outside the radical. In the because, there's still the exponent 2 because there's really a 2, it's just hiding. So let's think about what root c to the 12th really is. If we put some words to it, it's the thing that you square to get c to the 12th. It's in the same way, what's root 25? It's the thing that you square in order to get 25. Now we happen to know that the thing you square to get 25 happens to be a 5. In the case of just what's in the box above, the thing you'd square in order to get c to the 12th, well, that thing that you'd have to square would be c to the 6th. That's what's shown here with c to the 6th quantity to the second power equals c to the 12th.